right, let's try again. Here's lesson 6.2 on parabolas. And this is looking at it from a conic sections perspective. So you have this plane intersecting a double cone, and that creates our parabola over there. And we're going to be graphing parabolas, and we're going to write equations of parabolas. First, the definition of a parabola. It's the set of all points in a plane that are the same distance from a fixed line, called the directrix, and a fixed point, called the focus, not on that line. So here, parabolas can be oriented one of four ways. You can have them either be up or down, or left or right, depending on which term is squared. If I look at this equation for a moment, notice that the x is squared and not the y. There's no squared on that. So that creates an up or a down parabola. You've seen these in Algebra 1 and Algebra 2 as well. Some points of reference are vertex is at h, comma, k. And we also have this P here, which you might not have seen before. And that 4P, P tells us the distance from our vertex to our focus, or our vertex to the directrix. If P is positive, then it's opening up. If P is negative, it's opening down for one that has x squared but not y squared. Alternatively, I can take this same equation and isolate y. So sometimes you see it isolated as well. So if I was going to isolate y, there's that equation, would divide by 4p, which is really a 1/4 in front, so there's a 1 there. And then if I move that k over to the other side, so this is another format. We're going to kind of work with both of those. Now, if I have just the y squared and not the x squared, yeah, my y is squared, but there's no squared on the x. It also is a parabola, but instead of opening up or down, it's going to open to the right if it's positive and to the left if it's negative. So you could have it in this format where h and k is my center, or you can also have it where it's isolated for x instead of for y. So if I was going to look at what that, if I was isolating for x, I'd divide by 4p. We still get 1 over 4p. So we're either working with 4p or 1 over 4p, depending on whether we're isolated or not. The tricky thing is if I isolate on this, 4p is k squared plus h. The tricky thing on this, if I have an isolated one that's in this format, h and k corresponds to h comma k. So it kind of flips. We're used to, in vertex form from a parabola from Algebra 2, that my h and my k are located in those two spots respectively, and it's always in that same order. But when I have it x equals, they're flipped around because the k is with the y. It makes sense if you think about it that way, but it's backwards from usual. So determine whether each parabola opens upward, downward, to the left, or to the right. I'm going to start by isolating these. Here I have x is negative 1/4 y squared. Since x is equal to a negative y squared tells me it's either to the right or to the left. Since it's a negative, that's going to head to the left. Here I have y equals negative 6x squared. X squared is going to go up or down. Since it's negative, that's going to go down. Here I'm going to isolate another time. So divide by 1. X squared. So I have x squared, so that's going to open up or down. It's a positive, so it's going to open upwards. And here I have x equals 1/4 y squared. It's a y squared, so it's going to open to the left or to the right. And since it's positive, it's going to open to the right. We also have one other piece in our parabolas, and that's called a latus rectum. It's the line segment through the focus of the conic section, perpendicular to the axis of symmetry, which has both endpoints on the curve. Its length is 4p. So what that distant length is right here. So through the focus, perpendicular to the axis of symmetry, parallel to the directrix as well. And this whole length here is 4p. which means it's 2p on this side and 2p on that side. Okay, so that's the latus rectum. Okay, and I will say it's the absolute value of 4p because if p is a negative because it's going down, that distance still will be positive. Okay. So, identify the vertex, focus, directrix, and latus rectum length of the graph of each equation, and graph the equation. I'm going to kind of do them all around the same time. So I'm going to do this one isolated, so I'll divide by 4, negative 1/4, x plus 1 squared. So my vertex, and I have like a plus 0 there, my vertex is going to be at negative 1, 0. Now, since I'm isolated, we're going to pull this for our p-value, and it's going to be 1 over 4p. It's negative 1/4. If I wasn't isolated, it would look a little different. I'd be pulling from right there. So I'm going to cross multiply and get negative 4 is equal to 4p. Divide by 4. P is negative 1. So that negative is telling me that it's opening down. So negative 1, 0 is right here. 1 below it is going to be our focus. So that's negative 1, negative 1. Labeled with a little f. Our directrix is going to be 1 above. It's going to be a horizontal line. Horizontal lines are equals. And then our latus rectum length is the absolute value of 4p. So absolute value of 4 times negative 1, 4, which is 4. So 4 units long, which means, again, 2 on this side and 2 on that side. So the latus rectum helps us determine how wide that parabola is going to be. Let's take a look at the next one. Our vertex, I still have y equals. So our vertex here is, this one is isolated. So it's going to be positive 2, positive 3. This one is a positive in the front, so it's going to open upwards because it's a positive x squared. Then I'm going to take this piece right there, and since again it's isolated, I'm working with 1 over 4p. Cross multiply, 4p is equal to 8, p is 2. So vertex is 2, 1, 2, 3. So that's the vertex. Our focus is going to be 2 units above it. So 2, and then I'm going to add 2 to the y-coordinate. Our directrix will be 2 below. And you get the equation y equals 1 again. That's no coincidence. Our latus rectum length is going to be absolute value of 4 times 2, which is 8 units. Which means 1, 2, 3, 4 on this side, and 1, 2, 3, 4 on that side. And that makes our shape like that. Let's work with this one we'll work with this one isolated as well, because it's already kind of. So my vertex is going to be 0, negative 5. I have a positive x squared, so we're opening up. And 0, 1, 2, 3, 4, 5. So 1 over 4p is going to equal 1/4. Cross multiply. P is equal to 1. So our focus is 1 unit above, our directrix is 1 unit below. And remember, the directrix is a line. The most common mistake would be to write the directrix as a coordinate point when it's really just a line. Here we want to have the line y equals negative 6. Our latus rectum length is 4 times 1, which is 4 units. 2 on this side, 2 on that side. Take a moment, pause the video, and try this one. Did you try it? Okay. Alright, so x plus 1 squared minus 4 is negative y. So negative 1/12 plus 1 squared plus 2. So I could also, if I didn't want to isolate, I could also just factor out the negative 12. and work from here. If I'm working from here, we're going to have opposite and opposite. To be -1, +2. Does that match with here in opposite and regular? Yes, it does. If I'm working from this non-isolated version, I would have 4p is equal to -12, p is -3. If I work from this one, the isolated, -1 over 12 is 1 over 4p. All right, and so if I cross multiply on this, -4p is 12, p is -3. So I still get the same thing. Either way I do that. So my vertex is at -1, +2. And our focus is going to be 3 units below, because this is opening down. Down. 1, 2, 3. So there's my focus, which is a lovely -1, -1. And my directrix will be 3 above. 1, 2, 3. So we would say y equals 5. The last rectum length is going to be absolute value of 4 times -3, which is 12 units. 1, 2, 3, 4, 5, 6 on that side. 1, 2, 3, 4, 5, 6 on that side. All right, so here I have one that's not isolated, and I have a y squared. So I'm going to work with it in this non-isolated method. So opposite of ones that are with their variable. 5, -2. Okay, we all right with that? I hope so. So then this, that's my 4p is equal to 4, p is equal to 1. Again, so this is telling me my focus is 1 unit away. Now, this is a y squared. X is equal to a positive y squared. So, because this is positive for p also. So that tells me this is actually opening. Dun, dun, dun. Oh, there it is. This is opening to the right. So 1, 2, 3, 4, 5. 1, 2. There's my vertex. My focus is going to be 1 unit to the right. So that's going to be at the coordinates of 6, -2. Notice my x value changed this time because it's an x equals. And then my directrix will be 1 unit on the left of it. Now this is a vertical line, so it'll be x equals, and it's 1, 2, 3, 4. So my directrix is x equals 4. So again, notice my x value is changing, and it's x equals for my directrix. Everything should stay consistent through these problems. And then the last rectum is absolute value of 4p, so absolute value of 4, which is 4 units, which tells me 2 units above and 2 units below. And actually, when we take a look at these, every point on our parabola should be the same distance from the focus as it is the directrix. And you can see right here, that's 2 there, and that is 2 as well. So it is following consistently. Okay. Take a minute, pause the video, and try this one. This one is isolated though, so it's going to be a little bit trickier. So when I do this one, there's my y coordinate. And there's my x. Notice that the y is with the y. So when I write my vertex, it's going to be -1, +3. Again, this one's going to be opposite. I bet a couple of you have 3, -1. It's flipped around because the y is with the y. We want to always be really careful with that. That's the trickiest part on these. We have -1/8 is equal to 1 over 4p, and I'm using 1 over 4p because the x is isolated. We got 4p is -8. I just cross multiplied. It didn't really matter which side the negative went on, as long as I had only 1 there. P is -2. The fact that it's negative tells me it's going to the left. -1, 1, 2, 3. There's the vertex. My focus is going to be 2 units left of that, which will be -3, +3. And my directrix will be 2 units on the right. The vertical lines would be x equals 1. Our lattice rectum length is going to absolute value of 4 times p, 4 times -2 is -8, absolute value is +8 units, which will give me 1, 2, 3, 4 here, and 1, 2, 3, 4 here. All right, so you can also write the equation of a parabola. I'm going to do similar kinds of things. I'm going to find my p-value. So that from my focus, this is the focus. It's 1 unit away to the vertex. Same here, 1 unit to the directrix. So that confirms that it really is 1. Our vertex is at h, k, which is 1, 2. I'm going to work with the isolated format, but I could work with the other format as well. My p-value is 1 because this distance is 1. So 1 over 4, x minus 1 squared plus 2. Boom. All right, so take a minute and try this problem. Let's try it. So this distance is 2. I have a vertex at -2, +3. Do y equals, it's a negative because it's going down. 4 times 2 is 8. X minus negative becomes a plus. Boom. And do the same kind of thing for sideways ones. My distance here is 1. My vertex is at 3, 2. And again, I'm going to use the isolated one. 1 over 4 times 1 is 4. Y minus. Now, here's the trickiest part about this. The one that goes with the y has to be the y coordinate of the vertex. So y minus 2 plus 3. One more. So take a minute, pause the video, and try this one. Okay, so this distance is 2. My vertex is at 1, -1. So again, we're using the isolated format. So I'm working with the isolated version, which is x is equal to 1 over 4p, y minus k squared plus 8. So our p-value is 2, but it's going to be a negative because it's opening to the left. So we want to make sure we take that into account. So there's the negative. 4 times 2 is 8. Y minus -1 plus 1. So that's 1 squared plus 1. All right. So we're going to do this problem 2 different ways. Write an equation for the graph that is a set of all points in a plane that are, not area, equidistant from the point 0, 3 to the line y equals -3. So I'm going to go the quick way first, and then I'm going to show you using the formal definition of a parabola. The quick way would be to graph 0, 3, and the line y equals -3, 1, 2, 3, and very similar to how we did the last couple, we want to find where the vertex is. The vertex is going to be right in between those, so we're talking about 0, 0. And that makes our p-value 3. This is going to be opening up because the focus is above our vertex. And so we're going to have, from this format, y equals 1/12 x squared, and then plus 0, minus 0, and then a plus 0, but those are just gone. All right, so that was the quick way. Now I'm going to use the long way. I'm not expecting you to recreate this long way, but I do want to see showing from the formal definition. So the fact that this is equidistant, that means we're talking about equal distances. So actually I'll switch colors, so I'll do it in red. So I'm going to use the distance formula to figure this out. X minus x2 minus x1 plus y2 minus y1. Okay, so it's basically like I have some point here, and we call it x comma y, that this distance is the same as this distance. And obviously on my scale that's not correct, but roughly. So from my focus, which was at 0, 3, to the directrix. Now the point on this directrix is straight down, so x is the same as that x, comma -3 on the y. So somehow this distance and this distance have to be equal in order for that point x comma y to be on the parabola. So I'm going to do the distance between this point P and F, which would be, so from P to F is x minus 0 squared plus y minus 3 squared. Now the distance from point P to D, down here, I'm calling D, is going to be x squared plus y minus -3 squared. Now if they're equal distances, these have to be equal. So x minus 0 is just x. X minus x is gone because it's just 0. I guess I had to put 0 squared. That's fine. So from here, I'm going to square both sides to get rid of the radicals. And get rid of the 0 too, because it's not doing anything. And FOIL y squared minus 6y plus 9, y squared plus 6y plus 9. My y squareds cancel out, my 9s cancel out. X squared minus 6y plus 6y. Move this over. X squared is equal to 12y divided by 12. Y is 1/12 squared. I got the same answer, but a much longer way. And actually, as we go through this process, you can almost see where the 4p is coming from. When you square this, the middle term is 2 times that, and 2 times that, but they're opposite signs. And when you take one and move it to the other side, 2 of something and 2 of another something gives you 4 of it. That's where that 4p is really coming from originally. Write an equation for a graph that is the set of all points in the plane that are equidistant from the point 2, 0, right there, and the line y x equals -2. 1, 2. So again, I'm going to go the long route. I'm not expecting you to be able to recreate this long route. So if I have some point like here's x, y, 2, 0, this point is going to be x, 2. No, it's going to be -2, y. I apologize. That's how I drew it more accurate. So the distance between x, y, this point, and our focus point is going to be x minus 2 squared plus y minus 2 squared. The distance between my point P and my point D is going to be x minus -2 squared plus y minus y squared. So x minus 2 squared plus y squared, x plus 2 square root, and then 0 on that. Square both sides to get rid of the radical. FOIL my x squareds cancel, my 4s cancel. Now again, in the shorter way, I would have found what's in between this focus point and this directrix, and it's 0, 0. This distance is 2, so therefore it's got to be x equals, because we're sideways, 1 over 4 times 2 y squared. Okay. But I did want to show where the 4p is coming from, because I think that's an important step. All right, so just like all of our other conics, we can also complete the square with these. So we're going to complete the square to rewrite, and then identify the vertex, focus, directrix, and lattice rectum length. So we're finding the same things, but it's written in a different format. Now, in order to complete the square, we're going to do exactly how we did on the other ones, except I only have to complete the square once, because only one of my terms is quantity squared. So I'm going to take since my squared is y, I've got 2 of those y's, I'm actually going to move them to the other side. I'm moving them to the other side so my y is positive. It didn't really matter which way I moved them though. So then I have to think about what's going to go in that square. I have a 1 in front of my y squared, so I'm going to take the 20, divide by 2, and then square it. If it didn't have a 1 in front of the y squared, then I would have to factor. So that's 10. 10 squared is 100. I'm going to add 100. But if I add to one side, I have to add to the other side as well. So now I'm going to have x minus 3 is, and I'm going to factor this, y plus 10 squared. Now, if I'm isolating, we're going to have x is equal to 1 minus 10 squared plus 3. So my vertex, remember this is going to be with the y on that one, my vertex is going to be at 3, negative 10. Now I need to find my p-value. I'm isolated, so it's usually 1 over 4p. 1 over 4p is equal to 1. 4p is 1, p is 1/4. So it's not always an integer. I know all the other ones have been, but it's not always going to be. So 3, negative 10. That means our focus is only a quarter of a unit away. And since it's a positive y squared, it's opening to the right. And a quarter of a unit away is right there-ish, which will be 3 1/4 negative 10. Our directrix will be a quarter of a unit away on the other side. Give a line x equals 2 3/4, or equals, depending on if you're writing a mixed number or an improper fraction. The lattice rectum length is going to be absolute value of 4p. 4 times 1/4 is 1 unit, which means it's only a half a unit on either side. Very, very small. Okay. So again, today's goal was to graph parabolas and to write equations of parabolas given characteristics. And this concludes our lesson on parabolas, day 1.